Hello everyone, and welcome to video number 4. And last time we got this little window to show up, and yeah, all's well so far. Now, since the last video, I've discovered a little problem in our window system, and we're going to actually cover that. So, first we should fix one of the window bugs I've discovered. So if we head into the window thing, a little problem with default construction that actually happens is that if we default construct something, and in that case we actually never make sure that a valid GLW context is a thing. So when we actually try to update the context settings, it just kind of ends up failing. So the solution for this is just wrap everything in that handle. So only do it if the handle is valid. That should fix that little default construct bug. Now there's a couple other things we're going to get into as well. So inside this constructor, we're actually going to take in another value here. It's actually going to be a function pointer. And this will allow us to set some context variables for the window. And I'll say why we have to do it in here. So I'll call it, what's a good name for this? I'll just call it generic function. So I'm just using the C function pointer since in this case I don't really think it makes much sense to use the C++ one. And I'll just default it to null pointer. So what this function will let us do is basically right before we create the window, we can actually call this function if it's set. And for example, this is where we'd set our window hint values. For example, what context we're using, if we're going to use Vulkan, OpenGL context versions for compatibility, that kind of stuff. And it has to be after initializing the GLW, but before creating the window. And this is just the easiest way I found to actually get that in there. So I'm actually going to specify that here now. And I'm just going to put it in a lambda. And I could just specify the window hints now. Alright, and what these Windows hints specify is that we're just going to use OpenGL 4.6 core, and all you need to know about this is that it's going to just use the new OpenGL version, and we're not going to use any of the fixed function pipeline stuff. Okay, so next thing in our window is we actually do this error check in here, and I'm actually going to take this out, and we're going to move it out here. Since out here it makes a little more sense to do it, and we can properly react to it. In this case, if it fails, I'll just return -1 out of the main function. The next thing with error checking is this gladload.gl function here. And we have to check if that fails as well, and if it does fail, then we say failed to create, well, how about failed to load OpenGL? And that fixes this little issue, and we have our error checking. Now with those little issues fixed, we're going to talk about applications and states. So we're going to start with applications, and we're going to go straight into the abstraction parts. So we're going to start with the header, and I'll just call it, I'll give it the full name, application header. And we'll start defining what an application is. So an application is just the central container for our entire engine, just some global state we can access. Now for our application, we're going to give it default constructor and then a default virtual constructor, since this is something we will end up extending from. Oh wait, yeah, I don't know my return types. Okay, so we have our construction. We're going to have our start and stop. This will handle starting, stopping the thing. And then in our internal state, we're going to store this running flag, which is just a marker saying the engine's running or the application's running or it isn't. Now if we try calling start while the engine's running, then we're just going to return out the function, since we'll get all kinds of annoying behavior if we do this. Now, if we want to stop the engine, we can just set the run to false, and then the start function will handle that. So at this point, we can call some made-up functions I'll write in a moment. So first, we're going to initialize the application, and then while our running variable is true, we're going to call this update function, and at the end we're going to call this destroy function. And then these functions would actually just be pure virtual functions, and this is something we will enforce to put on our subclasses. So that's pretty basic so far. I'm gonna mark this stop as inline since no reason to really separate that whatsoever. Next, I could mark this inline, but it is a slightly larger function, so in this case I will put it in a CPP file, even though I'm almost 100% sure I don't have to. So in this case I'll just use IntelliSense here to generate that for me. And again, I just don't like how Visual Studio does a lot of things by default, so I'm just gonna use its template and just adjust it so it works nicer for me. There, and I think that looks fine. Alright, and this also makes it very obvious what stop does, but starts a whole procedure here. Alright, so let's actually create a subclass of this. So I'll just call it game, and it's going to subclass from tutorial application. And then for our game, we need the default constructor and that virtual destructor. And then obviously we gotta include our application header. Now as for what we need to store this, right now it's literally just a window. So we're going to store a window, and this should get default constructed as a null pointer, so it shouldn't touch any context or anything like that. Now the other thing that we need are these virtual functions. So let me find where I am. Okay. So I'm just going to paste them here, mark them override, and just provide the implementations. Like so. Now, what we do for all this, we can just kind of slot into where we want it to go. So one is our initialization code that we would do in our initialize function. Our update code is here, and that would go there. Then this makes our main empty, but we'll fix that in a moment. Alright, so when we actually want to initialize everything, we want to set the window variable in our actual class here, then just rename the variables. Now in the case where we have an error, what we can do is we can just call the stop function right away. So this means that our update will actually never run if the window fails, and we can just handle it like this. And I find this is a pretty nice approach when we have some pretty critical things going on. And speaking of critical, I'm going to actually change these to be critical errors since we legit can't continue if those fail. Then our update, very basic. Okay, and just one other thing. Now because our loop runs based off this run flag and not if the window's valid, we actually need to put an explicit check for this now. So we can say if the window should close, we can call the stop function, which will exit the application at the start of the next frame. So this stuff will still run, and yeah, it would work very nice. In this case, I think it'll make sense just to put at bottom. So now we have to worry about this whole application deal. So now for the time being, I'm going to get rid of this since we don't need it yet, but at some point we will. That just makes our life easier. So first we can create ourselves an instance of the game class here. And then all we gotta do is call the start function, and this will handle everything. So if we run it, everything should be successful, assuming I didn't make any mistakes. Awesome. And we get the same result, which is exactly what we want. Now we have to get into the whole thing about states. And I like to think about states in a way that is basically we have menus, games, the actual inside the game, or if we hop into options menus, that kind of deal. Those are pretty different code bases, so being able to swap out essentially what this update function is doing live would be extremely helpful. Now, of course, we don't have a very good way to do this right now, and that's what we're going to do right now. So we have our basic application, which is awesome as it is. So let's keep moving here. So we're going to define this right up here for the time being. So we're going to have our state manager, which will keep track of the currently set state. And then we can make multiple instances of this if we want to manage more than one state, and that's kind of that whole thing. Then we have the state itself. Now, the state manager, we really don't want to make subclasses of this, so I'll just mark it final just to prevent that explicitly. Now, for the state manager, I'm actually going to flip the order around here, and then I'm just going to forward declare the state manager, just so we can provide what we need. Now, for the state manager, having some kind of user pointer like GLFW actually uses would be extremely helpful, so I am going to implement something like that. Now, part of me wants to attach it to an application, but I don't think that we really want to enforce that kind of restriction on this. So, everything our state has right now, it will have the void initialized, so when we set it, if we want to do updates, very similar to the application actually. And if we set a different state, then we have some destroying to do. Then these are going to be, again, just pure virtual functions, just force them to be implemented. Then I'm going to provide the defaults for these. Since it is virtual, we should have a virtual destructor. And that's all a state really is. Now, for consistency, again, I'm just going to make it a class. Then I'm going to make this protected, which I rarely use in C++, but we're going to have a pointer to the state. In this case, I'm just using a raw pointer here, which, hate me all you want, but in our case, I don't think it's going to really cause any problems whatsoever. So, if you want to use your whole shared pointer stuff, then feel free to implement that over this. But for simplicity, and I don't really think we need shared pointers for this usage case, since more likely than not, we're just going to use one state manager and attach it to the application. So then we have our state manager, and again, I'm going to provide, well, in this case I don't need these at all, so I'm not going to bother with them. So we're going to have our, just a set state function, and this just takes in a state pointer. And then we have some kind of state pointer currently set. So that's very easy to do. Now I'm also going to provide a user pointer, just so we can put our own data into this when we want. In my usage case, we're just going to be passing the user pointer this application. So I'm going to also provide that user pointer, get user pointer, since that's going to be a very helpful thing to be able to access, especially in the states when we actually want to touch things in the game instance here. So when we get to set and state, we're going to touch upon in a moment. So there's also the updates, which will essentially, if we have a valid state set, then we will call its update function, like so. Now, to set a state, we have to first check if our current state is valid. If we have a current valid state, then we have to basically destroy everything. And then we have to set its manager pointer, which is right here. And we set it to null pointer, just for a consistency thing here. And then I'm going to actually friend class state manager here, since this is a little exception here. And yeah, so if there's a current state set, we destroy it and we reset its pointer. So at that point, we're just ready to overwrite this pointer. So we just set the pointer equal. And we have to be careful with this as well, because we could say just unset the state and pass it null pointer. So after we set the state, if it's set to something, we need to actually initialize it. But again, it might call some into our manager, so we just set it to a pointer to this. Alright. Now, I'm going to actually make this a private, and I'll just make a function to do this. Get state manager. And in this case, I can just easily set it as a const. Same here, just the whole const correctness thing. And I'm going to double check window actually, because yeah, I actually do forget it here as well. So I'm just going to throw that in while we're messing about with const. So to get our state manager, we just return the state manager. And I'm just going to rename the variable if it wasn't obvious enough. It's not going to hurt to make it more obvious. So setting the state is pretty basic. So we can set state, we can update a state if it's set, and we can retrieve our user pointer. And then since we actually have this state itself, we can retrieve a state manager and then get the user pointer like so. And then we'd have to use some of our casting to be able to use it. So this is our little state implementation, and we're going to put it in its own file to keep everything clean. So in this case, I'll just use one header file, since I think 2 is a bit overkill for this. So we're just going to cut and put it in here. And let me just hop over, copy, paste the namespace, because I'm lazy. I'm a programmer, of course I'm lazy. Alright. So now we're gonna make that CPP file. State CPP, I'll just do the copy paste. And then I will selectively pick what we put where. So in our header, before we declare this, we have our functions that, now this we can just inline it and it'll be fine. Let's see. Yeah, so state we can just, we don't even need anything special for it. Our state manager, again, these two make perfect sense inline to me. The only thing that I wouldn't is this, just because it's a bigger kind of function. Now again, odds are just inline it anyways, so not a big deal. In our state CPP, we don't have to touch any of that. I only decided to put this in here. So that's all I have to move. And there we go. Life is easy. So in our entry point, along with window and application, we can include this whole state system. And now we get into another detail, which is like if you want to set the state while it's running, that could also pose some issues. And we'll talk about that at another point, since that's going to be a whole nother system we'll have to build to get working correctly. But what we can do now is, inside our game, we can actually have a state manager. And I'll just do it at, let's just do it at the end of our initializing here. So we can take our state manager, and there's a couple things here. One, we have no way to set the user pointer, and you think I'd actually add that, so let's add that. So we're gonna set user pointer, void pointer, pointer. since we want to be able to access things like that. So now we can actually set that, which is required. So we can set our user pointer just to be pointed to the application. Easy enough. But then we want to set our state to something. And right now this is just a pointer. So we do have to have some kind of storage for this. Now the obvious solutions would be using unique pointers and using standard move operations and that kind of deal. And in this case that actually does make sense to have the state manager own the states. So that's one thing I'm going to implement now actually. Now, in terms of using pointers for the state itself, like passing back to the manager, I think we'll leave that a raw pointer. And when we push a state, we can just specify a type and it'll handle that. So, which actually will mean we don't need to specify this since it'll be templated. So let's do that real quick. So in our state header, I can just kind of stick that in place again. So I'm just gonna say template type name T, and then, and you never know, we could pass things like arguments to it. So we're gonna want to be able to forward that. So in our state manager, I'm gonna include our memory header. So we're gonna do that. So our state is going to be a standard unique pointer of type state. And yeah, that seems fine to me. Since I don't think we'll need shared pointers or anything, I think ownership makes complete sense like this, so fine by me. Alright, so when we actually set the state, we can use standard make unique of type T, forward our arguments into that construction. So, for example, if we have certain variables we want to set, we'll be able to provide them in our set state. So in this case, I think, yeah, because this will do the destruction, it will handle all of that kind of stuff. And I think that will work completely fine. And let's do some testing on that now. So we create our state manager, and we want to set that user pointer, but of course we need some kind of state to set. So I'll just call this a test state, and it will inherit from our state, and it's gonna have very similar things to here, but slightly different. So what we can do now is things specific to states we can put into here. So for example, our states themselves, they wouldn't have to touch any of this kind of stuff, which makes life super nice. So what I'm going to do now is we can set our state, and we can use this template argument for the test state. We can just set it like that, which I think works pretty nice. Now, we might get some issues with public-private stuff. Now, I'm not going to bother writing the constructor because I don't think I need it. No, I'm going to bother writing. I did it for everything else. I'm going to do it again. Okay. So we actually can set our state like this. And now all the state would need to worry about is handling, for example, it wouldn't need to touch polling event, wouldn't need to worry about swapping buffers or figuring out if we click the X button. So we can just take our state manager, and then we can we can just call update, and that will make sure it's valid. If so, we call into its functions. And for now, all it's going to do is clear the color to red and actually clear everything. So that makes this even nicer to use, which I'm a big fan of. Now there's another kind of bug that I want to talk about as well. So when we actually destroy the state manager object, we actually want to make sure that we have invalid state here. And that's because we'll say we have some OpenGL textures allocated in here, we actually want to make sure this gets deleted correctly. So what I'm going to do is I'm going to specify that destructor here. Now, again, I'm just going to provide it inline like so. It's final, so I don't need to worry about that. So what all this is going to do is set our state to null pointer. Now in this case, I do have to have something like this, because it expects to be able to do that. So I need to be able to set it to some null type. Yeah, another thing I could do is just handle it like that. If it's set, then just do all that. Which I think this is completely valid, but I would like to call into this. And you know what, I am going to look into details of this, but I'm not going to do it on camera here. Let's see. Alright, awesome. That is working. And then I got some inconsistent things here. State manager, inconsistent. Yeah, that's just class. Alright, that should have everything working as expected. Yep, awesome. So let's actually demonstrate a little more what this can do. So in our entry point, we have all this new code we can play with. Our main is as easy as ever. So let's say if we push a key, we can set the state to something else, or we could, yeah, let's just make a second state and give that state system a test. So I'll say test state 2. I will say that we will need to know about the actual state of each other to do this correctly, and we're gonna get that working when we get to that. So what we can do is that one, we're inside the state, so we don't know about really anything. So we can actually get our state manager as such. So we get our state manager, we can say, we can retrieve the user pointer, which is actually what we want. And then we can then cast it to our game pointer, like this. Now we can access content inside our game. Now, for example, we don't actually expose the window at all, so just for the purpose of testing this, I'm gonna expose that. So I can now access our window and retrieve its handle. And it's not the cleanest way to do it, but now we have a way to handle that. Now another way we could do this is we could just retrieve the global application if we wanted to do it something like that, but again, for the purpose of the state manager, we may not have a global application, and as of right now we don't. So we can retrieve that window handle, which is nice, and we can say yes, glw get key, and we actually have to provide that window handle. And we can say if key W is pressed. So when we first press that W key, we can do something. And the way this can work is we can retrieve our state manager. And we can set our state to test state 2. Now, the obvious problem here is that, well, it doesn't know about test state 2. And in this case, I'm not going to make it like recursive or anything of that nature. I'll just define it up here, and we can say draw it magenta instead. So then we have to be careful in terms of how this works, because we set our states so it would destroy what we're doing, and that's actually a very important detail, because this will actually call destroy as our update is running. So ideally we'd actually have a way to submit this to the application, and that's what we're going to talk about in the next video. But for now, we actually don't do anything here, so it's not a big deal. So this will work as is, but later on this will cause issues, so keep that in mind. So if we actually do that, it should build correctly. Oh, cannot be used before it's initialized. Let me look here. Identifier, it doesn't know about the game identifier. Yeah, that is to be expected. So, for now, I'm just gonna define it underneath here. There we go. And that's just so it knows what that game pointer even is. And then, again, that's why I like putting things in headers early on, just so we don't have that problem. So we have the window. If I make sure it has focus, tap the W key, it turns magenta. And that just shows that everything's working correctly. And we actually know that just because the way the code is structured, we're actually completely changing the states, and that's awesome, basically. Yeah, in tutorial 5, I think we're going to get some kind of submitting system and maybe even get a triangle rendering, which will be extremely exciting. So, thanks for watching. Bye-bye.